Composition of functions. Consider two functions, f from a to b and g is another function from b to c. Then we would be able to figure out a function which goes from a to c, and that function is simply we use f which goes from a to b and then g which goes from b to c. Then the function which goes from a to c would be known as function GOF. Then this function can be defined as GOF x equals to G f of x. So this O is known as either O, it is pronounced as O, or circle, or simply composite. Alright, okay, so that's the definition. Let's suppose these three circles indicates the sets A, B and C, and f is a function which goes from A to B, and g is a function going from B to C, and all these three sets are subsets of real numbers. Suppose we have a point x in A, then f takes x to B, whose name would be f of x. Okay, so simply it is x operated by f. Then again this point, whenever it is operated by g, then the resulting point which lies in C would be known as simply g of f of x. So this is how this definition is built up. So this is a very new way to find out new functions from old. And don't forget that GOF does not mean z times f. It is simply f of x is operated by g. You can see that by the definition. Okay, let's take an example. Here f of x is a function. By default we shall understand that f of x has domain and range both real numbers, and g of x also has domain and range to be real numbers. F of x is defined to be 2x minus 3, gx is defined to be x squared plus x, and we need to figure out the value of f composite of g, -1, and g composite of f. So this is simply f of g of -1. Okay, that's what we understand by the definition. Okay, since we know that f o g of x would be f of g of x. Okay, so that's the definition. Then now you can see that f g of -1, let us plug in this -1 in the formula of g. Okay, so x in the formula of g of x should be replaced by -1. X in the formula of g of x is replaced by -1. Okay, please be very careful about that. So that would be -1 square, that's simply 1, plus -1, which is simply f of 0. Okay, 1 minus 1 is 0. So f of 0. Now here we need to figure out the value of f of 0. So let us plug in this 0 in the function f of x. X in the formula of f of x is replaced by 0. Okay, so then what happens is that would be 2 times 0 minus 3, -3. So that is the answer for f of g, -1. Let us solve GOF of 1. So this would be definitely g composite f of 1. Here you can clearly see we need to replace x in the formula of f by 1. Okay, so that will give us g is in the front, and this would be 2 times 1 minus 3. So simply here we can write x in the formula of f of x is replaced by 1. This would be g of 2 minus 3 is simply 1. So we need to plug in this 1 in the formula. So what we will do is, here this x in the formula of g of x should be replaced by 1. So this would be 1 square and this would be plus 1. So that's 1 square plus 1. So here we can say that x in the formula of g of x is replaced by 1. That's it. So it will be 1 plus 1, which is 2. So that's our answer for GOF of 1. Please be very careful about these two steps, and if you are not confident, then please start to write this kinds of statement such that it will help you later on. Consider two functions, f of x equals to root under x plus 2 and g of x equals to 2 minus x square. We will find the general formula for f of g of x, GOF of x, and find their domain and range on both cases. Let's start the problem. So this would be f of g of x. So g of x is 2 minus x square, which can be simply written as 2 minus x square inside the parenthesis. Now the formula f of x, in the formula of f of x, this x should be replaced by 2 minus x square. That means x will be replaced by 2 minus x square. Root under 2 minus x square plus 2. So that's simply 4 minus x square. Okay, so we obtained the formula for f of g of x. Now what is the domain and what is the range? Okay, so it's very simple to find out what is the domain and range. Now if you consider y equals to root under 4 minus x square, then you might want to write this as y square equals to 4 minus x square, which is simply x square plus y square equals to 4. Okay, then well, here I squared both sides, so that's why I got this one. Then its graph would be something just like this. Okay, it is a circle. Okay, this is 2 and this is negative 2. This is the center, right? So 4 means 2 square, so that's why we have 2 as our radius. And since y equals to root under 4 minus x square, that means we will only have positive and positive values of y. So that's why the upper portion will only be counted in this case. The portion which is below x-axis won't be counted. Thus our domain is from negative 2 up to 2 and our range would be from 0 to 2. Okay, so that's all for f of g of x. Now let's go for GOF of x. G f of x, then this would be g of f of x is simply root under x plus 2. In the formula of g of x, we have 2 minus x square. Then each and every x in this formula should be replaced by root under x plus 2. Okay, then this would be 2 minus x square, means root x plus 2 whole square. Okay, so please take a very close look how I have done that. Then this square and square root, they cancel out, so we get 2 minus x plus 2, 2 minus x minus 2, so that's simply negative fx. Now to find its domain and range, it's not that hard. So domain of this function y equals to negative of x, right? If we consider this function GOF to be y, then y equals to negative x. It's very simple. Y equals to negative of x is this line which passes through the origin and makes 135-degree angle, and so that's it. So this is from negative infinity to positive infinity, or simply you can write the whole of r, and range is also the same. Okay, so range is also negative infinity to positive infinity and the whole of r. So look, they are quite distinct with each other. Then we can generally say that FOG is not equals to GOF. Okay, please be careful about that. Okay, that's all. Thank you.